Welcome to the training series of the SCORES project, where partners introduce the concept, technologies and their demonstration. In this video, partners from EDF and AEE INTEC will explain the demonstrations. What are the locations and buildings chosen for the demonstration and why?
In Agen, south of France, we have chosen a residential building to demonstrate the SCORES project. The residence is composed of 115 apartments. It's a typical construction for France and is compliant with the thermal regulation for building built after 2012. The warm oceanic climate and the internal insulation make it possible to have low energy needs for space heating. Therefore, there is no district heating connection.
The demonstrator in Gleisdorf, Austria, consists of an office building combined with 3 houses. The 2 buildings in the south are the office, and the row in the north are the 3 houses. All buildings are connected to the district heating system of the city. With this demonstrator, we can test how the SCORES system operates with a mix of office buildings and houses.
What are the SCORES system configurations being demonstrated?
The residence is equipped with multiple energy systems. For space heating, an air-to-air heat pump is used to provide both heat and cooling. For the SCORES project, some apartments were also equipped with electric heater panel with phase-changing materials for storing heat. For the domestic hot water, the building is equipped with hybrid photovoltaics and thermal solar collector. They provide heat to a water-to-water heat pump and renewable electricity to the building. The water-to-water heat pump is also connected to a hot water storage. On the electricity side, batteries support the system and reduce the need for electricity from the grid. A BEMS, Building Energy Management System, orchestrates the system and manage the energy flow between the components.
One part of the SCORES system is located in the central boiler room of the building complex. Here, 2 heat pumps provide heat for space heating and hot water. The hot water is stored in a buffer tank. A building energy management system, which is developed in the project, controls the electricity for the heat pumps. The electricity either comes from the PV, the batteries or the grid. This depends on electricity prices and local energy generation.
A second part of the system is outside, in 2 containers. In the left container are the electrical components, a PV on the roof, and inside are the batteries and the inverter, which connects the PV with the electricity grid. In the other container is a small hot water tank and a test version of the long-term thermal energy storage, called CLC. With this, surplus electricity from the PV can be stored as heat for a long time with very little losses, and then it can be used to heat up buildings in winter.
What are the key performance indicators being analyzed in the demonstrations?
By integrating several components, the SCORES system may represent some complexity. So first, we are analyzing the overall energy balance of the building per usage and performance of each component. For instance, actual coefficient of performance of heat pump are key figures. In the SCORES project, the main objective is also to demonstrate how we can optimally use local and renewable resources. Self-consumption and self-production ratio are key performance indicators in that regard. SCORES system is also connected to the electrical grid. So load curve describing extraction and injection into the grid is also monitored and analyzed. In addition, environmental impact are also analyzed through carbon emission and compared to the reference scenario.
The goal of the SCORES system is to optimally use the local available renewable energy in the building. The performance of the SCORES system is measured by a number of so-called key performance indicators, short KPIs. The most important indicators are the energy consumption of the building, the renewable energy generated on site, and the share of renewables in the total energy consumption. We also look at the hours in a year where the system runs only on renewable energy.
What are the main results obtained so far?
The key components for the SCORES system in Agen are in place. The BEMS, Building Energy Management System, and the communication to the other components still need to be validated. Based on monitor variables, space heating, domestic hot water, and other usage were also evaluated. This important milestone is crucial to calibrate the simulation model. They will be used in the end to operate the demonstrator and also derive the reference case. The test period will be carried out until the end of the project, and the demonstrator result will be analyzed all along.
Here at the Austrian demonstration site in Gleisdorf, we've already installed all of the main components of the SCORE system, and each of these have been tested individually with the BEMS algorithm. We will now begin the measurement period of the project, in which we will collect and analyze data for the complete SCORE system. At the end, we will then evaluate this data and the overall performance of the demonstrator. In parallel to the demonstrator, we've also built a number of simulation models with the purpose of being able to test the BEMS algorithm in a virtual environment. The second purpose of the simulations is to then build on a number of so-called SCORE's future system scenarios, in which we evaluate the performance of an optimized system with the technology scaled at the lowest possible cost.
Although the SCORE system has been validated and demonstrated in these two locations, is it easy to adapt and efficiently use in other regions, namely in Europe?
The replicability of the SCORE system is a very important outcome of the project. One of the main goals was to not only demonstrate the maturity of each of these technologies, but also to be able to identify key barriers which might hinder the integration in larger systems. So far, we've observed that all of the technologies in the Austrian site could be commissioned without the need for any deep renovation in the building. However, due to the differences in maturity of these technologies, technicians in the field were not always familiar with all of these. It is therefore a conclusion of the project that more work needs to be put into fostering training such that all of these technologies can be implemented in the overall system. Our simulation models are also an effective tool to be able to evaluate the performance of SCORE systems in different building types and regions around Europe, so long as adequate consumption data and weather data is available.
SCORES gathers 12 partners from 7 European countries who are working towards the common goal. Watch the next video in the training series. Visit the project website and follow the latest news on our social media.